The final project is about the sorting. So in this project, you will enhance your capability of coding sorting algorithms. Understanding the effect of big O notations on different sorting algorithms in detail. We talk about several different sorting algorithms. Some of the sorting algorithms require the big O of n squared. Some sorting algorithm requires n log n, and we have some also discuss the spatial sorting algorithms which will take only big O of n operation. And therefore, it is time for you to really run the code, run different algorithms, and then see what is happening between different sorting algorithms. So you need to implement the following 3 different sorting algorithms. The first one is the insertion sort. This is the sorting algorithm mainly for comparison purpose. Most of the programs you have wrote so far takes about 1 second to run the code. You basically hit Ctrl F5 and you show the outputs, and you will be able to see the results of your coding. In this one, especially the insertion sort, it will take a while because it's an operation of n squared, and it needs to apply on a relatively large data set. The data set is included in the project folder. So you can see that it has quite a few different numbers, and it's a lot basically. So you can see that if I keep scrolling down, all of these are the numbers that you need to be sorted. So all of these values are given in the file. You basically need to read in the file and then sort it based on 3 different sorting algorithms. Insertion sort, the second type is n log n sorting algorithm. So you can choose from either heap sort, merge sort, or quick sort. Whatever you choose is fine, but you need to choose one of that and implement it. Apply to sort the given data file. And finally, the third one is the spatial sorting algorithm. I want you to choose either counting sort or radix sort. I believe most people will probably choose the counting sort because it's relatively easier. But of course, you can have your choices. And therefore, you need to implement 3 sorting algorithms, apply on the same data set, sort it, and I want you to compare their execution time. So the input data set is given in the class website as well as the Blackboard. You need to record the execution time for every sorting algorithm and compare their performances with a table or figure. The recording of the execution time is not asking you guys to use a cell phone and then hit start and then record. You need to go online, search for the time recording library, and you need to find a way to record it. For example, this is something that you need to think about. You can start the recording process from input and output, from reading the data set until it's totally finished. You can use that. And of course, you can also record the time only taking consideration of the program execution, which means that excludes the file I/O. There's a lot of different possibilities over here. This project is not about right or wrong. It's not about like, can you implement the sorting algorithm? One more step further is that I already think you should be able to implement all 3 of the sorting algorithms easily. Now I want you to do basically some research about these 3 sorting algorithms. Try to compare. Try to understand the difference between n squared versus n log n versus big O of n. Which one can really tells you, which one can really helps you finding the sorted segments in a very, very fast way. Compare with n squared, obviously you know that it will take a while. Sometimes minutes, sometimes hours, depending on how you implement it. So you better have some outputs during the process. Also, recording the execution time, you will notice that second is not the best way to record it. Because when you comparing the second sorting algorithm versus third sorting algorithm, if your time unit is second, you will not be able to tell the difference. That's based on my experience. Of course, you may see different things. And therefore, you need to find a scientific way to really compare all of these things. Also, including sometimes you run the same code on the same data set and end up with slightly different execution time. So how would you choose the one that to do the comparison, or how will you handle those kind of differences are all included in this project. So now, not only you need to write the code for 3 sorting algorithms, you need to find a way to compare them fairly. So that is the major part of the project. On top of that, you also need to describe how to use multiple CPU, and I'm just say 2 of those, using 2 CPUs to parallelize the radix sort given here in the given data set. Be as specific as possible. So saying that you try to parallelize, you know how to use 2 CPUs, and then you try to use 2 CPUs to parallelize the code for a radix sort. Of course, you don't really need to write the code because this class is not about the parallelization, but I want you to think, if you know how to use 2 CPUs, how would you make your radix sort run faster? So the project will due by the midnight of the date given in the blackboard. This is an individual project, so you need to work on your own. Your personal honor is more important. So what you will need to submit is the following things. First of all, 1-page description, double space, size 12, including figures that compare the execution time of different algorithms and on different, not really the operating systems. So you just focus on the different algorithms over here. That's the first page that you need to give me. The second page is the 1-page description in English. Remember, you don't need to write the code. You just need to think and tell me how would you want to do that. Of how to use 2 CPUs to parallelize the radix sort to sort the given data set. This data set is the example I used for the radix sort in the lecture. So think about, I want you to apply radix sort on this 8 elements, only 8 of those. But now you have 2 CPUs, so how would you parallelize your operation? So be as specific as possible, and what you need to submit is 1-page description of the comparison, 1-page description of the parallelization about the radix sort when you have 2 CPUs, and finally the source code of your program. The rubric is provided as well. So 30 points is about the correctness, and I'm just assuming you would be able to get all 3 sorting algorithms runs correctly. That's about the correctness. To do the comparison as another 30 points. So I want you to be as scientific way as possible. Try to do a good analysis, and that's something I want you guys to think about. Readability of your code, parallelization. The second page about the radix sort parallelized with 2 CPUs. This is something I want you to think about. So that was another 20 points. And finally, try to deliver it on time. And that is about your final project.